Hey everybody, it's Miss Bell here from the Science Lab, and right in front of me I have so many fun things that I got from home from my kiddos' room. As you can see, I have a bunch of different animals, and I even have a jar of plants that are about 2 or 3 weeks old. They've seen some better days, but they're still making it. They still have a little bit of time left before they completely die. But with my plant and my animals, I am going to consider these to be living organisms. Even though my stuffed animals are not real animals, I'm going to pretend that they are living animals. And when we talk about living organisms, our plants and our animals, well, they all interact with each other in regards to what we call food chains in science. Food chains are extremely important to life itself. We would not be alive without food chains. My mouse right here would not be alive without some sort of food chain. And when you talk about food chains, it is taking energy from another living organism and putting it into your body. And it's a flow of energy from one living organism to another living organism. So the way that we get energy, well, where does that energy come from? How do we get energy? Every living organism needs energy. My bunny cannot hop without having energy to do it. My butterfly right here can't fly without having energy. My snake can't slither on the ground without having energy. And there are ways that living organisms gain energy. Now plants, like my flowers right here, or grass or trees, they are going to get their energy in one way, and that comes from the sun. Yeah. Plants get their energy from the sun, but animals get their energy either from plants or from animals, and that is whatever they eat. So the sun is going to help my plant grow its own food, and then there's going to be certain animals that are going to eat the plants, and then there's going to be an animal that eats that animal, and then another animal that eats that animal, so on and so forth. So if you take a look at all my living organisms, what kind of food chain do you think you can make? Think about it. Think about it. We know it's going to start with the sun. The sun is going to help my plant grow. And then an animal, I'm just going to choose a bunny, is going to come and eat my plant, nom 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 flowers, nom 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 grass. And then there might be another animal that comes along and eats my bunny. I'm going to say my snake right here. My snake is going to come along and eat my rabbit. So the energy passed from my flower to my bunny. And then the energy in my bunny passed from my bunny to my snake. And so on and so on and so on. That's how food chains work. It's so cool. So one big thing to think about when you're talking about food chains is the word interdependence. This is when living organisms, like those plants and those animals, depend on each other for their own survival. So animals need other animals, or animals are going to need plants. And this might be in the form of needing shelter, like for protection, or needing some sort of food for them to eat and survive on, or maybe even, believe it or not, air And the way that we get air, well, that depends on us as animals and plants. So living organisms always rely or depend on each other in order to survive day by day. Okay, so to talk a little bit more about how animals and plants rely on each other as far as breathing or air goes, let me explain it and try my best to break it down for you guys. So when we breathe in and out, there's a lot of things happening all at once. The same thing that we breathe in is not really the exact same thing that we breathe out. It's really kind of tricky to understand, but I'm going to try my best to explain it. When we breathe in something called oxygen that is coming into our bodies, into our lungs, that helps us breathe. But whenever we exhale our breath, when we're breathing, it's called carbon dioxide. Really tricky, I know. That is what's leaving our body. Let me try to show you. Here we go. Okay, I'm breathing in. I'm breathing out. I'm breathing in oxygen. I'm blowing out carbon dioxide. So it looks like this. Now you might wonder, where is that oxygen coming from for us to be able to breathe it in, and what happens to that carbon dioxide that we're blowing out of our bodies? And that's the cool thing with kind of depending on plants and animals. We have to rely on plants. That's going to be your trees, your flowers, your grass, your bushes, your shrubs. We have to rely on these living organisms to help us breathe. And guess what? Vice versa. They have to rely on us in order for them to breathe and survive. Okay, I use little hand air quotes because yes, plants breathe and take in carbon dioxide. It just doesn't look the same like us. Like our chests move, and when it's really cold we can see our breath getting really foggy. But let me show you what it looks like with a plant. Here we go. I'm going to try my best. Okay, so when the plants get that sun, the sunlight energy, they are also taking in carbon dioxide. Okay, and whenever they go through photosynthesis to create their own food, they are going to release oxygen. Whenever they release oxygen, we animals are going to breathe it in. And whenever we exhale, our carbon dioxide goes into the atmosphere, and the plants take in that carbon dioxide along with the light energy from the sun. They go through photosynthesis again, and they are going to release oxygen into the atmosphere, and that's what we breathe in. And what we breathe out, it goes right back to them. What they release goes in the air, we breathe it in, and whatever we release goes back to them. It's kind of tricky to understand with how that kind of works and how it rotates, but just remember, we wouldn't be able to breathe the oxygen that we breathe without the help of plants. They wouldn't be able to breathe without the carbon dioxide coming from our bodies. Isn't science cool? I love it. So jumping back to food chains, Remember, it's the flow of energy. How do we show that flow of energy? If you look in between all of my living organisms, you're going to see these red arrows, and they are pointing a specific way. Let me say that one more time. It matters how the arrows are pointing. The way that the arrows need to be pointing with your food chains is how that energy is flowing from one thing to another thing. So this living organism has gained the energy from that. Take, for instance, every food chain begins with sun. We need sunlight to go to our producers. Those are going to be our plants, our trees, our leaves, our bushes, our grass, our seaweed. You see how my arrow is pointing to my leaf? Because the energy from the sun is going to my plants, to my producer. Then from there, since my caterpillar is going to eat my leaf, my energy is going to flow to my caterpillar, So that's why my arrow is pointing to my caterpillar. Then from there, my bird is going to eat my caterpillar. So the energy from my caterpillar is then going to be transferred to my bird, so on and so forth. So those arrows make a difference on which way they are pointing. Remember, you are pointing to the living organism that the energy is flowing to. Now, food chains can differ from what this one looks like to what this one looks like, and it all depends on an environment. Where is this place located and what lives in it? What kind of plants are there? What kind of animals are there? A swamp habitat or environment is going to look different than a forest habitat, and that's going to look different from a desert habitat. So all of these food chains are going to look different from one place to a different place. And it really also depends on what those animals eat. Some animals can be considered herbivores. Say it with me. Herbivores. Herbivores are going to eat only, let me hear it, they are going to eat only plants. That's right, herbivores eat only plants. That could be seeds, that could be fruit, that could be veggies, that could be leaves or flowers, trees or bushes or grass. Other animals are going to eat animals. They are called carnivores. Say it with me. Carnivores are going to eat only, let me hear it, animals. Carnivores eat only animals. That could be fish, that could be lizards, that could be insects, that could be snakes, that could be rabbits, that could be a fox. And then there are animals like us humans that eat both plants and animals. We would call that specific animal an omnivore. Say it with me. An omnivore is going to eat only what? Plants and animals. There we go. There we go. So a food chain is going to depend on what kind of habitat we're talking about and what kind of diet those living organisms have. So I'm going to teach you guys a song that will help us remember some of those diets of different animals. Remember, an animal is going to be either an herbivore, where they eat plants, a carnivore, where they eat animals, or an omnivore, where they eat both plants and animals. So I have my lyrics or the words to my song on paper, so I'm going to be holding it up as I sing, and every time we see a red word like this, you're going to kind of shout it out, like herbivore or omnivore or carnivore. And this is the tune to what it's going to sound like. So listen up. Listen up. Ready? Okay, are you guys ready? Yeah? Yeah, you want to be silly with Miss Bell? I'm ready to sing. Okay, let's get to it. Let me hold my signs up correctly, and then we're going to start singing our song. Ready? Okay, here we go. Oh, I wish I were a hungry herbivore, herbivore. Oh, I wish I were a hungry herbivore, herbivore. I would eat plants and seeds and munch on some weeds. Oh, I wish I were a hungry herbivore, herbivore. One more time. Let's sing about herbivores again. Ready and go. Oh, I wish I were a hungry herbivore, herbivore. Oh, I wish I were a hungry herbivore, herbivore. I would eat plants and seeds and munch on some weeds. Oh, I wish I were a hungry herbivore, herbivore. Oh, I wish I were a hungry carnivore, carnivore. Oh, I wish I were a hungry carnivore, carnivore. I'd eat lots of meat since it's a tasty treat. Oh, I wish I were a hungry carnivore, carnivore. One more time. Oh, I wish I were a hungry carnivore, carnivore. Oh, I wish I were a hungry carnivore, carnivore. I'd eat lots of meat since it's a tasty treat. Oh, I wish I were a hungry carnivore, carnivore. Oh, I wish I were a hungry omnivore, omnivore. Oh, I wish I were a hungry omnivore, omnivore. I'd eat meat and plants, could be leaves, mice, or ants. So I wish I were a hungry omnivore, omnivore. One more time, last time. Oh, I wish I were a hungry omnivore, omnivore. Oh, I wish I were a hungry omnivore, omnivore. I'd eat meat and plants, could be leaves, mice, or ants. Oh, I wish I were a hungry omnivore, omnivore. Great job, second grade. Yay, yay, yay. Thank you for singing with me. Yay! So I want to show you guys how you can make a food chain model. What I'm going to do is take 2 pieces of paper and some coloring utensils and put my creativity to play. So the first thing I need to do is think of a habitat, and for this activity I want to focus on a forest. So in my habitat picture I'm drawing different living organisms. I have grass and trees, I have a bush that produces berries, I have mushrooms and a mouse. I also have a snake and some birds and a fox. You can also include in a forest habitat maybe a squirrel or a rabbit, maybe even a hawk or a deer. But with this activity, I am choosing only one food chain. That is where I can see the flow of energy from a producer to a consumer. So I am choosing to focus on 4 living materials, or living organisms. My producer is going to be my berries. My next item in my food chain is going to be a grasshopper. We know that grasshoppers, like insects, are going to be herbivores, and they are considered consumers. My next living organism in my food chain is going to be a mouse. And then also, my mouse is considered an omnivore depending on its diet, and they are also considered a consumer. And then finally, in this particular food chain, I have a fox who eats only meat, so they are considered a carnivore. And because they are eating another animal, they are considered a consumer. So you are able to see from all the different folds that I'm playing with my papers and the way that I'm drawing and labeling everything, that it kind of looks like a folded fan, or like an accordion, if you know what that musical instrument looks like. So in the final product, I'm able to expand my forest habitat to show you that flow of energy from the berries all the way to my fox. So another thing I want to talk about in regards to food chains are decomposers. Now, I haven't talked yet about what a decomposer is or how it works in the food chain, but just believe me that without decomposers, we wouldn't have healthy habitats. We need decomposers. So what is it? What do they do? Where can we find them? What are some examples? Well, let me answer all those questions for you. A decomposer is a living organism that is going to feed off of the remains of other plants and other animals. Some examples of decomposers might be worms or mold, maybe fungi like mushrooms or bacteria, maybe snails or beetles, or even slugs. Sometimes we might think, ooh, gross, those things are disgusting. Even if you think that, that doesn't change the fact that these decomposers are crucial to a healthy environment. And what they feed on is sometimes considered organic material or decaying matter. Decaying means dead. So they might feed on dead plants or dead animals. And when we talk about the remains of animals, that might mean also maybe like animal poop, or if you're talking about fruit, like the peels of animals. Certain decomposers kind of latch on and munch on those and eat those. Now, what do they do with all these crazy materials? If they eat animal poop, why is that so important? If they eat dead animals, why is that so important? Well, there's a process. So they are going to eat those remains of the animals, and then inside their bodies, they're going to break down those materials into nutrients. And what do they do with that nutrients? I'm so glad you asked. With that nutrients, they're going to put it back into the soil. That's going to make that soil super healthy, super organic. And plants need healthy soil in order for them to grow and thrive and survive. So that's why decomposers are so important with food chains. So here I have my stack of many food chains within one big food web. And the difference between a food chain and a food web is, look at my food chain right here. I have sun, then seaweed, then shellfish like oysters, then jellyfish, and then a turtle. So that's my food chain pathway. My turtle is going to eat my jellyfish and get energy from the jellyfish. My jellyfish is going to eat the shellfish, like my oyster. My oyster is going to eat my seaweed, and my seaweed is going to make its own sort of food by using sunlight. Here's another food chain. My eagle is going to eat eel. The eel is going to eat crab. The crab is going to eat phytoplankton, and then phytoplankton are just really, really small microscopic algae. They need sunlight in order to grow. And all of these food chains put together, all of these different pathways of energy flowing from one living thing to a different living thing is called a food web. When you talk about food chains, another thing to keep in mind are these two important words, prey and predator. You might have heard those two words being used before when you're talking about animals eating animals. So here I'm just mapping out a very simple food chain, starting with the sun and going all the way to a hawk. I've labeled which of my living organisms are consumers or producers. I've also labeled which are herbivores, omnivores, or carnivores. But pay attention to my labels as prey or predator. So are they being hunted? That is considered a prey. Or are they the ones doing the hunting? Those are considered the predators. So, all in all, just remember a food chain is the energy passing from one living thing to another. Take, for instance, our sun. Remember, from the sun, we're going to get light energy, and that's going to go to our tree. Our tree is going to produce food that our grasshopper is then going to eat. Then a bird is going to come by and eat our grasshopper, so energy is going to pass to the bird, and then nom 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 nom, a crocodile is going to come and eat our bird and get energy from our bird. And that's just the flow of energy from the sun to the tree, from the tree to the grasshopper, from the grasshopper to the bird, and from the bird to our crocodile.
Nom nom nom.
Thanks so much, guys. Bye.
Bye.